Hello and welcome, geometers, to another lesson with Mr. Forster. Today we'll be going over Lesson 5, Proofs with Parallelograms. If you're wondering where Lesson 4 went, Lesson 4 was technically your quiz on Lessons 1 through 3. So this is now transitioning into Lesson 5. Let's go ahead and get started. The textbook section that we're looking at today is 7.3, titled Proofs with Parallelograms. So far in Unit 7, we've looked at the different properties of polygons, and we looked at some of the different attributes that are interesting about parallelograms. And so now we're going to look at if we have those attributes, we can use them to prove whether or not we have a parallelogram. A parallelogram is a quadrilateral with both sets of opposite sides that are parallel. And then a reminder, the angles of a quadrilateral will always add up to 360 degrees. Let's go ahead and dive right in. We're going to look at a few example proofs today, showing some of the different theorems that we have. So in proof A over on the left, we're given that we have this quadrilateral broken up into these four smaller triangles here by the diagonals. And we know that angle JKN, which is this top right, kind of the upper angle here with the one arc, we know that is congruent to angle LMN, which is this bottom angle in the bottom left here. We also know that angle LKN is this top angle with the two arcs, and then that's congruent to JMN, which is this bottom angle with the two arcs. And our goal is to prove that we have a parallelogram. So let's go ahead and see if we can do that. As usual with these proofs, we're going to start with our given information, which is that these angles are congruent. From here, if we know that these angles are congruent, then we can say that JK, which is this top side up here, is parallel to ML. And the reason that we can say that is we have alternate interior angles using this angle here and this top angle here. So the single arc angles are giving us that JK and ML are parallel. And then the double arc angles are telling us that the two sides on the left and right, JM and KL, are parallel. So because we have these two pairs of parallel sides, well, by definition, that's what a parallelogram is. So that's what we would say, that JKLM is a parallelogram because it meets the definition of a parallelogram. In our example B here, we're given that we have these two triangles now, so we only have one diagonal, but we're told that these two triangles are congruent. So we have TRS, which is the upper left triangle here, and we have RTW, which is the bottom right triangle. And we want to prove that RSTW is in fact a parallelogram. So again, as usual, we'll start off with our given statement. So we know that these two triangles are congruent. The next thing that we can say is by corresponding parts of congruent triangles being congruent, we have a few angles that are congruent. So STR, so that's STR, that's this angle up top here. That's going to be congruent to WRT, which is this angle down here. And then we also have that WTR, which we'll mark with two arcs this time, is congruent to angle SRT. So S, then R, then T, so the vertex is at R. And you notice that we have something very similar to what we had before. So by these two triangles being congruent, we get the same angle relationships that we had in part A. So we can make the same claim. We can make the claim that ST is parallel to RW, and then we can also make the claim that SR is parallel to TW. I realize I didn't color code this in blue, but that's all right. SR and TW are parallel, ST and RW are parallel by the alternate interior angles theorem, or converse in this case. And again, we have a situation where, by definition, when we have these two pairs of opposite sides, we have a parallelogram. So RSTW is the definition of a parallelogram. Next, we're going to walk through a few of the theorems that we can use. And the first one says that, well, if we have opposite sides and both pairs of them are congruent, then the quadrilateral is in fact a parallelogram. All right, so I need that this side is congruent to this side and this side is congruent to this side. So if I have both, again, without any additional information. I need both pairs of opposite sides to be congruent. Then I can say for sure it's a parallelogram. For the parallelogram opposite angles theorem, well, based on some of our discussions in class, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram as well. So if I have this top left angle and this bottom right angle are congruent, and if I also have this top right angle and this bottom left angle are congruent, then this would also be an instance where I do in fact have a parallelogram. We can also use the diagonals. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if I have this situation where I know that this diagonal is split down the middle, so this is the midpoint of that diagonal going from top left to bottom right. I also have the situation where my second diagonal is also split down the middle, and I have something that looks like this. So this is congruent to this segment from here to here, and from here to here. And then these two smaller diagonal segments are also congruent. Then this is a parallelogram. So if we have one pair of opposite sides of a quadrilateral, and it's both congruent and parallel, then it's a parallelogram. So I'm going to use the two sides kind of on the left and right here. If I know that this is congruent, and I have the fact that it is also parallel, which you'll see the arrows and you'll see the tick marks showing both of those things, then that's also a case where it's enough information to say that this is a parallelogram. All right, let's look at some sample problems that you might see from your textbook or on your Unit 7 test. So here it says we want to find the values of each variable which would make the figure a parallelogram. So I'm going to start off with part A, and then I'm going to let you give part B a try on your own, but I'm going to go ahead and start us off on part A. So for part A, in a parallelogram, we know a few things. We know that consecutive angles are going to be supplementary. So based on this, I'm going to take these two expressions that have A in them, since they're my angles Q and R and they're consecutive angles, and I'm going to add them together and set them equal to 180. From here, I can combine like terms, and A makes 2A plus 40 is equal to 180. From here, if I subtract 40 from both sides to isolate my variable on the left, then I'm going to have that 2A is equal to 140. And finally, if I divide both sides by 2, I would get a value of A is equal to 70. When A is 70, it makes these two angles supplementary. Next, I know that opposite sides should be congruent. So I'm going to take these two opposite sides, QP and RS, which I know the expressions for, and 3C minus 3 is going to be equal to C plus 1. From here, what I want to do is I want to isolate my variable. So I'm going to start off by adding 3 to both sides. That's going to leave me with 3C is equal to C plus 4. Next, I'm going to subtract C from both sides to get rid of the variable being on the right-hand side of my equation. That leaves me with 2C is equal to 4. And if I divide by 2, finally I get that C is equal to 2. Next, in part B, I want you to pause the video and try on your own, and then I will go over my solution here in a few seconds. All right, one of the things that I know in part B is that diagonals should bisect one another. So these two values of y and 3x should be equal to one another. Well, the other diagonal should also be bisected, so I'm also going to say that 2y minus 7 is equal to y plus 2. And here I have a system of equations. Now, one thing that I notice that stands out to me is, well, the second equation only has one variable, so we can solve for y right away. So that's what I'm going to do. And if I do that, I'll take that second equation there and add 7 to both sides. That gets rid of the minus 7 on the left. That leaves me with 2y is equal to y plus 9. There, if I subtract y from both sides, I will get that y is equal to 9. And now, to solve my system, I can substitute the value of y back into my first equation to get the value of x. And that's going to give me that 9 is equal to 3x, and that x is equal to 3. All right, part 9, we'll walk through some of these, and I want you to, again, try these on your own. So see if you can determine whether or not there's enough information in the diagram based on the 4 theorems that we have Pause the video now, and I will go through my solutions here in a few seconds. All right, part A. The first thing that I notice is that angles A and C are congruent. The next thing I notice is, well, if those two smaller angles that make up angles B and D, since the two of them are congruent, their total angle will also be congruent. So since the top of the two arcs here is the same as two arcs here, one arc is the same as the one arc here, the total angle of B and the total angle of D will be congruent as well. So in this case, we can say yes, because both sets of the opposite angles are in fact congruent. In part B, you might be tempted to say yes, but in this case, we don't have that opposite sides are congruent. We have adjacent sides that are congruent, or consecutive sides. So we would need these to be in a different arrangement. So we do not have enough information to say that we do in fact have a parallelogram. Part C, this one is yes. We have one pair of opposite sides that is both congruent, which is the little tick mark here, and parallel. So because QP and RS are both congruent and parallel, this does in fact make a parallelogram. And then finally, in part D, you might be tempted to say yes. However, the diagonals are not actually bisecting one another. I would need the single tick mark to be on both sections or segments of the same diagonal. So I don't have what I need in order for me to say without a doubt that this thing is in fact a parallelogram. All right, geometers, that concludes our lesson 5, proofs with parallelograms. Please check Google Classroom in the post that you found this video for the assignment. It should also be available to you in the Unit 7 packet. The assignment list should be there if you're following along with myself or Mr. Swatala's classes. As always, if you have any questions, feel free to reach out to your teacher and we would be more than happy to help out. Otherwise, have a fantastic day and I will see you in the next one.